We've talked about the definitions of expressions, equations, solution sets, and so today on this video we're going to talk about the definition of the graph of an equation. So essentially the graph of an equation, if we have an equation in two variables, say in the variables x and y, we're going to take all the solutions and we're going to graph the solution set. So if I've got a point on the graph of my equation, that means if I substitute x equals a, let me do that, x equals a and y equals b, we have a solution to our equation. Okay, I think I got it. There we go. So here's an example. Is 2, 3 a point on the graph of 3x squared plus 4y equals 2? So there's a question. Here's our equation. I don't need to keep doing that. Here's our equation. We're trying to think about points on the graph. So 2, 3 is a point on the graph if and only if I substitute 2 for x and 3 for y, I get a true statement. So we need to check. If we substitute 2 for x and 3 for y, do we get something that is true in this mathematical sentence? So we want to know if those two sides, those two expressions are equal. Well, on the left side we get 3 times 4 plus 4 times 3, we get 24, and 24 is not equal to 2. And so our answer is no. 2, 3 is not a point on the graph of 3x squared plus 4y equals 2. There's no way. Okay, if we want to actually find a point on the graph, we need to think about points that actually are on the graph of 3x squared plus 4y equals 2. That's a harder question than if I just say, is 2, 3 a point on this graph? If I say if 2, 3 is a point on this graph, all we have to do is substitute 2 for x and 3 for y and see if we get something that's true. If I ask you, name a point on this graph, that's harder. We actually have to come up with an x and a y that are solutions. So let's try another one. Is 4, 5 a point on the graph of xy plus x equals y minus 1? This would be a good time for you to pause the video and try it yourself and see if you can answer this question before I do. I am going to go ahead and check. So my check is, if I substitute 4 for x and 5 for y, do I get a true mathematical statement? So I want to know, is 4 times 5 plus 4 equal to 5 minus 1? And of course on the left we get 24, and on the right we get 4. That's not true. So the answer to the question is no. So actually it's quite a special thing to be a point on the graph of an equation. So let's try to take that very same equation and see if we actually can come up with one. So for example, I want to know what is a point on this graph. Okay, well, I might say, what if x is 1? If x is 1, I get y plus 1 equals y minus 1. And after a bit of examination, you might realize that this can never be true. Okay, so I've got to start over. There's no way for x to equal 1 because I end up with this equation, which can never be true. Y plus 1 can never equal y minus 1. So let's start over. Let's start with a different x. Why don't we start with x equals 0? If x is 0, then 0 equals y minus 1. Because what did I do? I substituted in 0 for x in both of these places. Okay, if 0 equals y minus 1, then y equals 1. That tells us that 0, 1 is a point on the graph of xy plus x equals y minus 1. I just as easily could have started with a y value. I could have started with y equals, I don't know, let's start with y equals 2. If I start with y equals 2, I get 2x plus x equals 2 minus 1, which tells me 3x equals 1. So if 3x equals 1, then x equals 1/3. Okay, that tells us if y equals 2, then x equals 1/3 on this graph. So I could also write that 1/3, 2 is the point on the graph of xy plus x equals y minus 1. Notice that the x-coordinate always comes first, followed by the y-coordinate. That's part of our Cartesian coordinate system. That's how we always write it. X comes first and then y. Let's do one more example. This is from a set of notes I had on a previous course, so that's why all the extra stuff is there. But what I really wanted was this example here. So on this graph, the graph here, here we go, the graph there, we have this graph, and we want to explain why the graph is not the graph of y equals x squared plus 2x plus 3. So you might think about it to yourself a little bit before I go and tell you. But remember, a point is on the graph of an equation if it is a solution to the equation. And a point is on, so every solution is on the graph. So let's say we take some point on this graph. Let's say the point 2, 3. 2, 3 is on the graph. Well, what we can do now is check in this equation and say, is 3 equal to 2 squared plus 2 times 2 plus 3? Okay, well, that right-hand side actually equals 11, and 3 is not equal to 11, and so that's why this is not the graph of y equals x squared plus 2x plus 3. That's just one reason. It's not the only reason, but it's one reason. Okay, so what is another reason? Well, let's look for a point that should be on the graph. Let's say if x is 0 in this equation, then y should equal 0 squared plus 2 times 0 plus 3, which is 3. So 0, 3 is a point on the graph of y equals x squared plus 2x plus 3. But, oh, here's the point 0, 3, and it is not on the graph on the right. So again, this is another reason why the graph below is not the graph of y equals x squared plus 2x plus 3. So we're going to do some graphing in class to help us get used to it, but hopefully this gives you a sense of what we're looking for and what is going on when we're graphing equations.